So now we will do a multiple feature selection using regression F test. This is a second type of F test because we have discussed we have two types of F tests. One of them is regression F test. So using regression F test, we can do multiple feature selection at a time. So identifying impactful independent variable combinations on sale price, and that's what we are going to do. This is an example here. So data will take a real world example to demonstrate how to select multiple features using the regression F test, where sale price is our target and categorical variables are our predictors. So as usual, let's begin with our first step one. We will look into the problem statement. The objective here is to find the best combination of features that have a statistically significant relationship with the target variable. And once the problem statement is decided, obviously I want to do multi-feature selection at one go. So now I need to write a hypothesis formulation. So null hypothesis basically means there is no significant relationship between the set of independent variables and the target variable. That's what is our null hypothesis. And if you deep dive into that, because what you see is a mathematical equation: beta 1, beta 2, beta 3, or beta sub 1, beta sub 2, beta sub 3. These are all coefficients of a multiple linear equation. So here when I say h sub 0, such that beta sub 1 equal to beta sub 2 is equal to beta sub 3 and so on, beta sub k is equal to 0 means this means that there is no significant relationship between the set of independent variables, a combination of features, in this case represented by beta sub 1, beta sub 2, beta sub 3 and so on, beta sub k, and the target variable. Okay, so that's our null hypothesis. Now let's write alternative hypothesis. Alternative hypothesis here is beta sub I not equals to 0. So that's what is our alternative hypothesis. So this means that there is a significant relationship between the set of independent variables. A set of independent variables are nothing but combination of features represented by beta sub 1, beta sub 2, beta sub 3 and so on, beta sub k and the target variable. Okay, so in the null hypothesis we assume that all the coefficients beta sub 1, beta sub 2 and so on, beta sub k are equal to 0, indicating no relationship between the independent variables and the target variable. And the alternative hypothesis states that at least one of the coefficients is not equal to 0. At least one, the most important thing to be remembered. See, at least one. So the alternative hypothesis states that at least one of the coefficients is not equal to 0, indicating a significant relationship between the independent variables and the target variable. Okay, so that's what is our hypothesis formulation. Now let's move on to the step 3, which is load and prepare data. So let's load the data set into a suitable data structure, example a data frame, and perform any necessary pre-processing operations which are required. Anyway, so the data set has been loaded and this is our data set, df data frame. So this data frame consists of five variables: bedrooms, bedrooms, square footage, location, age of house, bathrooms, and sales price. So bathrooms, that's your 1 2 3 discrete. Age of house 34 25 4 26, it's again discrete. Location, it's categorical, or you can say multinomial. Square footage, again your discrete or can be continuous variable. And bedrooms is again a discrete. And this is what we have. So sales price, so out of this, sales price is my target variable, and remaining are my features. Okay, this is what my data set total 10,000 rows and 6 columns. So when I execute this code while I'm teaching, if I execute this code on when if I execute the model on this data set, it's going to take huge amount of time. So that's the reason I have typed the code early, and I'm just gonna explain what I have done. That's it, simple. So that the time it's gonna take for that video, the duration of video can be reduced. Okay, let's move ahead on to the next step. So let's get back to the slide. So now it's define the variables. The next step is to define the variable. So we have to identify the target variable and the features, and that's what we're gonna do. So here, so before that, whatever tools which are required, all has been libraries and modules has been imported. Pandas, spd, iter tools, import combinations, because here we need to have a combinations of the data. And we have sklearn, this is to make a linear regression model. And then f regression is to calculate the f value, and this is what the libraries that we are going to import. Now let's scroll down, and some, the categorical variable has to be converted into the numbers, rural, suburb, city, and that has been encoded. You see that I have used this get dummy, and that has been encoded. It's fine. So all data has been encoded properly, not an issue. Now let's move ahead. So for me, so here the features, x are the features and y is my target variable. So y, you can clearly see sales price, and x is other than sales price. So list of combo, I put it list of combo. So combo is nothing but all other features. Okay, so I'm gonna show you. So this is my target variable, sales price. Sales price is my target variable, and other than sales price, rest all are predictors. You see that bedrooms, bedrooms, square footage, location, age of house, bathrooms, everything are my predictors. Okay, so let's get back to the slide now. So next, step 5 is to perform linear regression. Fit a linear regression model using the selected independent variables and the target variable. So that's what I'm going to do here. I have done it earlier. So I have called up the respective model, and I'm going to instantiate the class object. And here you see I have instantiated the class object, and then I have fit. I used the fit method to fit it. But here what I did is, so initially I made a features combo. I'm going to show you, because before we perform, we have to see what all combos we have. So let's see. Let me print here. I think here it's okay. Print combo. And here you can see that. So these are the total combinations we have. The first combination is only one feature, one predictor, and second also one predictor, third one predictor, this. So total 5. The first combination, target variable bedrooms, target variable square footage, target variable age of house, target variable bathrooms, target variable location of urban, and all. So because this location of urban has came into the picture, because that has been encoded, the categorical variable which is urban city, this one has been encoded, and that's what this one has been made. And similarly, first we have tried with individual feature, then we have tried with double features, then with the three features, you see that, then with four features, and finally you have gone with five. Of course, whatever we have, everything we tried out, and these are all various combinations that we can have. Combination where order doesn't matter. Okay, where order doesn't matter. So that's what these are the combinations for each combo. So this is our combination list. You see that this is our combination list for each combo. I'm gonna fit the each combo will be fit into the linear regression, and we'll be creating model for each combo, and then for each combo we'll be calculating f values and p values. Okay, let's see that too. So let me print here, print f, sorry. Okay, that we'll see later when that step comes, but till now whatever we have done here so far is fitting the model to the each combo. That's it, performing the linear regression to the each combo. Okay, because we have multiple predictors, we want to select multiple predictor. To select the multiple predictors at one go, we need to apply the linear regression for the each combination, and it's gonna calculate, it's gonna take up the coefficient value for each combination, and it's gonna do the f test. Okay, let's move ahead, and the next step that we have here is calculate the F statistic. The F statistic measures the ratio of the explained variance to the unexplained variance in the regression model. So it assesses the overall significance of the set of independent variables. So this is how we calculate F statistic when it comes to a regression F test. Okay, so it is explained ESS, it's explained variance to the unexplained residual, we call it as unexplained variance, and obviously divided by k, and this is n minus k minus 1. So where k is the number of parameters in the model, and r S and small n is the number of observations, and ESS is the explained sum of squares, and RSS is the residual sum of squares, and ESS can be calculated from the total sum of squares minus RSS, that is a residual sum of square. This is what we call it as a ESS, which is explained variance. We call it RSS is unexplained variance, and ESS is explained variance. Explained variance can be calculated from the TSS, total sum of square, minus RSS. Okay, so where TSS is the total sum of squares, and how do we calculate? We can use a scalar library and F regression method or module. Then using F regression class object, we can calculate F values and P values. And let's do it, because we have applied a linear regression to each and every combination. So these many combinations we have, and we have applied to each and every combination. So now what we are going to do is we are going to calculate the F value for, because each you have the different regression models. Now you have to check the effectiveness of assess the regression statistical significance of the each combos model, so that we can get which feature is statistically significantly connected with our target variable. So that's what we're going to do. So print, let me say, yeah, so f values and p underscore values. Yep, that's it. And let's give the respective values, f values and p values, and execute. And here it is, here it is, This is your first combination, target variable with bedrooms. You got the 25. Your F statistic is 25. It's staggeringly very high. And p-value is 0.015, so it makes sense. And you got the square footage. It's 507, staggeringly high. So, and your p-value is 0.00. It's lesser than the 0.05. It also makes sense. And similarly, we have calculated the f value and p value for each combination. Each combination, you see that? You see that for each combination we have calculated. Okay. Square of footage, age of house, bathrooms, location urban, and for each combination we have calculated the p value and f value. So now let's move ahead. So now let's determine the critical f value. So determine the critical f value. So choose a significance level alpha to determine the critical f value for the given degrees of freedom. So what does that mean? So I have taken the alpha, which is 0.05. Okay, so that's what my alpha, that's what normally we consider. So now let me come here. If we take one example, so where my, let me scroll up here. If I take bedrooms, let's take location where you have uh, 3, I think rural suburb 3. Okay, and if you come down, let's take any example, so where we can have a numerator degrees of freedom as 4, and the bottom as maybe total sample of data set minus 10,000. So I'm going to go for this value. So then, so my at a level of significance 0.05, the critical f value is 2.417. If it is 1000, the critical f value is 2.417, and if it is 100, it's 2.463, and if this degrees of freedom, if it brings to this, it's 3.087. This is how you calculate the f critical. Of course, you can directly calculate f critical even from the stats module using the level of significance. Okay, so now let's so once you have decided with the critical f value, now it's time to compare the f statistic with the critical f value, or p value of f statistic with the level of significance, whatever is fine. So I'm gonna use p value and level of significance because that's what a data scientist normally do. So that's the reason. So these are my f values for various combinations. So for each combination, I'm going to compare p value of the respective combination with respect to the 0.05. If p value is less than 0.05 for the that combination, then I'm gonna eliminate that. If it is less than that, then I'm gonna consider that combination as a significant. If it is more than that, I'm gonna eliminate it. Okay, I'm repeating this again. If my p value is less than 0.05, then I'm going to consider that combination as a significant, whereas if my p value is greater than 0.05, I'm going to eliminate it outright center, outright left and center at that moment. Okay, so that's what I'm gonna do here. And finally, once everything is done, all set, then I can just print the results. But before we do that, let's move on to the next step. So now we have to interpret the results. So based on the comparison of the f statistic with the critical f value, or p-value of the f statistic with respect to the level of significance, which is 0.05, make a decision to either accept or reject the null hypothesis. Now let me get back to the action here. So now let me execute this, and let's scroll down, and here if you see, let me put the here a little bit of gap. Yeah, so here, if let's bring the significant combinations with f values and p values, and these are the significant combinations we found. So combination 1 that we have seen, and combination 2 square footage, combination 3 bathrooms, 4 worked out bedrooms and square footage. You can see that your their f values are this much, and you can see the p value. If you just compare, the p value of each is less than 0.05. This combination is less than 0.05. This combination is also less than 0.05. This two, and even this two, and this is very, very less, and this all three are lesser than 0.05. So that's the reason these combinations, we feel it as a significant combinations. Okay, now let's move ahead, look into the final step. So let's perform the feature selection. So select the combination of features that have a statistically significant relationship with the target variable, and this is the piece of code that we can use. So by following these steps, you can perform the regression F test for feature selection. It involves formulating the null hypothesis and alternative hypotheses, performing linear regression, calculating the F statistic, and comparing with the critical F value to determine the statistical significance of the relationship between the set of independent variables and the target variables. Let me get back before I wrap this up. So after this is what I call it as a multiple feature selection using regression F test or overall F test, and these are the features that I have ended up. So these are the combinations of features that I have ended up. Now there is a question, out of this combination, which combination has to be chosen? That's the next question you have to answer. How do you do that? That's very important question to be answered, because when you have multiple combinations, then how will you choose the best one? So then this is called as a data scientist's thing. The data scientist has to use his uh, intellect and his knowledge, his experience, and his domain expertise, and a lot of other factors comes into the picture to select one combination out of this. Okay, let's cross check that also. Now uh, before we optimizing before we finding the optimum combination uh, for our regression, for our linear regression, multiple linear regression, I need to give you one note. That is, in the context of the F test for feature selection, the null hypothesis assumes that the selected combination of features does not have a significant impact on the target variable, while the alternative hypothesis suggests that there is a significant relationship. So here, as a conclusion to this, before we going on to the optimizing the feature selection, so what we are saying is, we reject the null hypothesis here, because our null hypothesis says that there is not even one combination has a relationship. There is no significant relationship between even one combination with the target variable. But whereas our alternative hypothesis says there is a significant relation between the set of independent variables, at least one has a relationship. And here in our example, we have 7 combinations. You see that we have 7 combinations. Hence, we reject the null hypothesis here. We reject the null hypothesis and we say that there is a significant relationship between a 7 set of combinations, 7 combinations, or a few set of independent variables represented by beta 1, beta 2, beta 3 with our target variable. Okay, so all done, all set. Now it's time to optimize the feature selection. So that's what we are going to do. So selecting the optimum combination from significant independent variable combination. So we got the 7 significant independent variable combinations. Out of that, I'm going to choose one, which is optimal combination, I call it. This is what a data scientist's approach. So to choose the best combination from the seven significant combinations, we have to consider multi factors or multiple factors, such as the first one is domain knowledge. So domain knowledge or domain expertise is very important. If you are not sure about the domain, I would request you to communicate or contact the respective person, domain expertise, to take the final decision. Don't blindly take any decision. Okay, so here and evaluate the significance and relevance of each independent variable in the context of the problem domain. So prioritize variables that are known to have a strong impact on house prices. And second, interpretability. So interpretability is very important. For that, you require some amount of domain expertise and as usual and as well as statistical intuition. So select combinations that are interpretable and make intuitive sense. Consider variables that have a clear relationship between the house prices and can be easily explained to the stakeholders. This is very important. Either whether you work with a service based company or product based company, because I have worked in service based company, now I'm working in product based company. The most important point for a data scientist is whatever step you take, however the way you select the feature, that should be explainable. Why you have taken, why you have selected that feature, how do you explain that? Do you have evidence to convey to your stakeholders that this is the reason I'm taking this? So this, I have a strong evidence to say that there is a relationship between them, that's the reason I have taken. So that's the reason, as a data scientist, you should be very clear why you are selecting this feature. So that's the reason sometimes we don't use dimensionality reduction methods in extracting the features while doing feature engineering, specifically with respect to the service based companies, where you will be answerable to your client, why did you choose this feature? Okay, so that's the reason. Interpretability also, you have to make sure of interpretability. Also select combinations that are interpretable, very important, and make intuitive sense. It not just for you, it's even your stakeholder who doesn't have a knowledge on AI should also make intuitive sense out of it. So consider variables that have a clear relationship with house prices and can be easily explained to stakeholders. Next, model performance. Model performance, train regression models using each significant combination and compare their performance metrics such as R squared, root mean squared error, RMSE, or mean absolute error. Choose the combination that yields the best overall performance on your chosen metric. This is the next step you can take over to final to have a detailed evidence to uh, to support your action, to support your interpretation, to support your to support your feature selection method. So then we have the consider feature redundancy. So this is a normal step. So if some combinations contain similar variables or variables that are highly correlated, consider selecting the combination that offers the most unique information without a redundancy. This can help avoid multi-collinearity issues and hence model interpretability. So the last one is to practical considerations. You have to take practical considerations into account by practical limitations or constraints such as the availability or cost of collecting certain variables. So choose combinations that are feasible and practical to use in real world scenarios. So by considering these factors and conducting further analysis and experimentation, you can identify the most suitable combination of independent variables that provide the best predictive power and interpretability for your specific house price production task. So in our case, out of these seven combinations, just bedrooms can't make sense and square footage is not enough. So bathrooms again not enough. So if you see overall interpretability and domain knowledge and even model performance, I haven't tried, but considering the practical consideration, I would like to go with bedrooms and square footage and bathroom. So all three together will make your sales. All three together will make you make will predict the sales of house or price of house in accurately with more precisely. So that's the reason my this is my optimized combination. So that's the reason I'm gonna go with the bedrooms, square footage, and bathrooms as my features to do the further regression model.